And we're live. Sorry for the delay. Sorry for the hiccup. This happens once in a while with Google Hangouts, unfortunately. So we are live with Virtual IoT Meetup. It's great to be back. Today we're going to be talking about fog computing, kind of a foggy topic, or maybe we have two people from AD-Link and from the Eclipse IoT and Eclipse fog05 community, so Angelo and Gabriele, and yeah, they will tell us all about, well, one, what is fog computing, and two, what is Eclipse fog05, and I think we even get to see a cool demo today. So yeah, thanks everyone for your patience. As always, questions, you could send those, you can send your questions to the on the YouTube chat, and I will be monitoring them, and we will be forwarding those to Angelo and Gabriele when they're done with their presentation. But please don't wait until the very end to send those questions. You can also engage on Twitter using the Virtual IoT hashtag. And without further ado, Angelo and Gabriele, welcome. Thanks for your patience as well. And yeah, the floor is all yours.
Okay, thank you very much, Benjamin, and hello to everyone from Angelo.
Hello everyone, from Gabriele.
And Gabriele. So the plan for today, as Benjamin quickly mentioned, is that we'll try to explain and motivate why we need fog computing. After that will be hopefully clear for everyone, then we'll introduce fog05, and indeed we will do a demo. Okay, and as tradition requires, we will conclude to try to summarize, where we are going, what are the plans, and how the Eclipse community and anybody interested in fog computing actually can contribute. But before getting into fog computing, I want to give a very quick introduction to the ATO. So AD-Link, many of you probably will know, it's one of the main vendors of technology addressing edge computing for hardware, mostly hardware and software. And the ATO is the Advanced Technology Office. So that's the office of the CTO. So I'm the CTO of AD-Link. And our mission is really that of accelerating the rate of innovation in AD-Link. And it's articulated across 4 pillars. So the first pillar really has to do with scouting new technology, new technology that are emerging in a way and still a little bit immature, understanding applicability, and helping maturing those technologies so that we can more quickly apply them into product, identifying gaps, and helping filling those gaps. And for instance, all the activities around fog05 and the Annexus project, as you will see, really address the problem that we see today, which is the fact that everyone wants to do edge computing. Everyone talks about edge and fog computing, but the reality is that the bulk of the core technology is missing. And we will see what is our play there. The second step is innovating. Innovating in the sense, really reducing the risk and accelerating the innovation within our BU. There is always some form of resistance from BU in any company. And as you're probably familiar with, the role of CTO offices is really to facilitate that. We do a lot of communication, write lots of papers on IEEE, ACM conferences. That's quite important for us to really establish and advance the state of the art, also with respect to academic contribution. And obviously, all of that is done for improving the overall competitiveness of our company. Within the ATO, it's an interesting organization because we look after R&D in software and hardware. So it's worth to know that within our group, for instance, there were some of the people that did the design for the fog node reference architecture for the Intel architecture, for instance. And there is this dichotomy because on one hand, we do R&D on anything distributed, okay, from real-time distributed embedded system to extremely large-scale distributed system. And you could see and think of fog computing as well as our activities on low-power network and devices as indeed specialization of the general, let's say, topic, which for us is distributed system. Okay. For what concerns hardware, most of our focus is on heterogeneous computing infrastructure. Why so? Well, if you are trying to bring the control, computation, and keep information on the edge, you will need more, in a way, computational power per watt. And that can only be achieved if we do very smart design of hardware that leverage CPU, GPU, FPGA, and any kind of potentially ASICs that might be relevant for an application. So all of that is done within our group, and really try to address what is called as heterogeneous computing. Also from the aspect on how to make that easier to program. Because one thing is to design the hardware, the other then is to program, and today there are still some hardware with respect to that. I think our group and our company has received quite a few recognition in the past years, in the past few years. The latest two were, for instance, that we were named as the Compass Intelligence Award winner for 2018 in IoT and M2M, as an IoT and M2M company. And recently, myself was named as one of the top 50 influencer in edge computing. I think that's good, because it shows that we are there, that we've been there for a very long time. And for what concerns, for instance, fog computing, we were among the people, or the kind of people, that really were involved with it since the inception. Other important point is that the way in which we approach innovation is really trying to find the right balance and blend between theory and practice. And I think that's also reflected in the people that you see shown in this slide. Okay, so for us, innovation really has to come at the cross point of advanced theoretical science and indeed real problem that we want to solve in a creative manner. So that's how we position, and I think that's not unique, but at least our way of going. As a result, you will see that in some of our projects, we use sometimes tools and techniques that are considered exotic, but we think that that exotic is necessary to build software that is correct, that is secure, and that is performant. Okay, but we'll probably dedicate another webcast to those techniques and tools. Okay, let's try to understand now what is the state of practice in, let's say, IoT, so the Internet of Things. So if we look at the state of the practice today, most of the IoT applications are really built around what is known as the cloud-centric paradigm. What does that mean? Usually you have devices that are on the periphery of your system, and those devices communicate with software that is hosted on typically a public, sometimes a private cloud, where you do the analytics, you do the storage, and you do the control. So that's the dominant architecture. And many people would ask themselves, yes, what else, right? You give me an espresso, you give me a cloud provider, what else? Well, actually, there are the core assumption that are underlying cloud computing architecture are not so universally applicable as many people would like to think. So let's try to see what are some of the assumptions that are usually not, let's say, true for IoT system in the most general, let's say, interpretation, and especially if we start looking at what some people call the industrial IoT system. The first assumption that you have in cloud computing is that you usually have sufficient bandwidth to push data to the cloud. Okay. Now, if you keep in mind that a small to mid-sized smart factory produces half a terabyte of data per day, and that's today, and with digitalization, this will increase by a few factors. That already tells you that unless you have a huge pipe, okay, even if you had 50 megabit per second, it would take 48 hours, and that's an relatively expensive link to have. So this idea that bandwidth is not connectivity, bandwidth to the cloud is not an issue. Doesn't hold true for all applications. Might be true for application like a smart home where you are producing small amount of data, but not necessarily for this kind of application. Let's look at the assumption number 2 that underpins cloud computing architecture. That is that connectivity is not an issue. So essentially, there is the underlying assumption that devices will be almost always connected to the cloud. So have you ever taken a ride on the Alps or on any rural area? So the connectivity perspective is quite different, and most of your devices will be searching for an operator for quite some time. So while it's true that in a downtown, you might have very good connectivity. Eventually, we'll have very high bandwidth with low latency thanks to 5G. That won't necessarily be true everywhere. Most of the time, farms are indeed in this environment. If we want to have some form of autonomous vehicles, they might also require to run in this environment. So how do we address the problem? The third assumption that you have in cloud computing is that latency is not an issue, or at least latency that data has to experience when going from a device to the cloud, being manipulated on the cloud, perhaps by analytics and other software, and then conclusion or decision being pushed back to the edge, are usually fine. Well, but that really depends on the system, okay, and the dynamic of the system. So let me give you an example we've been involved with, and there is some of our technology that actually is used in this system, which is autonomous vehicles. You hear very often talking about driving cars, but as of today, in agriculture, there are already autonomous vehicles. These vehicles usually are harvesters and combiners, and they move autonomously on a field. From time to time, they pair, and they drive at a distance of 15 to 20 centimeters, okay, to actually coordinate and drive at 30, 35 to 40 miles an hour, okay? So the latency and the dynamics of the system is not at all compatible with what a cloud would provide. Besides the fact that in this kind of environment, at best, usually you get 2G connectivity to a cloud. The fourth assumption is that the cost of connectivity is negligible. Well, for that, you should really talk with smart grid operators. As of today, there is a huge push, especially in Europe, toward technology like LoRa and Sigfox, precisely because the cost of connectivity is high. Why? In these systems, the one who pays for connectivity is the operator. In a consumer IoT system, it's us, the consumer, as part of our mobile or home data plan. But there is the operator. And because of the number of devices or sensors that have to produce data is very high, this cost, from an operational perspective, is not at all negligible. They count bytes, okay? The same actually applies in all exploration rigs, as another example. The last point I want to raise that sometimes is underestimated is that there is this general assumption that perhaps companies and individuals are indeed comfortable in exposing data to the cloud. Are you sure? Okay, so the question is, then what do we really need? Okay, because in a way, cloud computing provides us with an operationally convenient set of abstractions that we can use to manage and provision data center resources. But if you look at the reality, or the, not just a subset of the reality, but most of the systems that we're dealing with, they just don't live inside the cloud, okay? Or they can't live having the infrastructure being deployed just inside the cloud. So what we need is an infrastructure that allows us to federate compute, storage, I/O, and communication resources, regardless of their location, and overall across the continuum that goes from the cloud to the thing. So this brings us to the definition of fog computing that was eventually agreed in the context of the open fog that I'll read for you. So fog computing is an horizontal system-level architecture that distributes computing, storage, control, and networking function closer to the user along a cloud-to-things continuum. So once again, you have the boundaries between the different layers that you might have in a system really blurring, and your infrastructure becomes a continuum, as we will see. And providing you an infrastructure that allows you to operate under this blurred and, in a way, assuming that the infrastructure really is a continuum, is really the goal of FogOS. So what is the vision that we have for FogOS? So FogOS goal is to provide you with a decentralized infrastructure, and I think it's very important to emphasize the fact that it's a completely decentralized infrastructure that allows you to provision, manage what? Compute, storage, communication, and I/O resources that might be anywhere across the network. So we put emphasis on I/O resources because in a typical data center, you actually don't care about I/O. In a general, let's say, 5G or IoT system, I/O is actually quite important because, especially if you consider industrial system or telco, that makes all the difference. Okay. The other important point is that FogOS was designed to address highly heterogeneous system. That's another big difference that you have as soon as you move out of the typical consumer IoT to the industrial or the more general IoT systems, in which heterogeneity is far more extreme, and more importantly, you have to face resource-constrained node all along the the cloud. It might be a private or a public cloud to the things continuum. And in some instance, you might not even have a cloud, but if all of a sudden you forget about barriers and you think and you have an infrastructure that just federates compute, storage, and I/O and networking resources across network-connected devices, that's all you care. So, as I mentioned before, FogOS design is decentralized. So you can manage and provision any network-connected device as far as we have our agent running on it. And this architecture doesn't require any special server residing or services residing on any specifically identified server or on necessarily very high-end machines. Okay, so that's by design. FogOS is an Eclipse project and has been an Eclipse project since February. So we are very proud of being part of the Eclipse IoT community because we think it's one of the most active IoT community. And I think the Eclipse community overall was very sensible to the gap that we have with respect to technology in this specific domain. And I think it's also important to know that FogOS has been identified as being compliant with the 5G principle as lined up by the European 5G PPP. And there is a white paper through which we provide references that you can read that in details. And it's also compliant with the Open Fog reference architecture. By the way, it's used in a quite few test beds, especially in some of the Asian initiatives. We have active users in some of the leading 5G R&D initiative in Europe, most notably 5G Coral and 5G City. Just a couple of weeks ago, we did a demonstration of a smart mall, and we have done quite a few demonstrations also where we were provisioning systems that were spanning from a cloud down to robots using ROS. And as you can see from the press, it is at the foundation of some experiments that are done in some cities across Europe, such as Lucca, Barcelona, and Bristol. Last slide before moving to a little bit more technical details on FogOS is that FogOS is one in an ecosystem of technology that as ATO we are really building, addressing the edge. And FogOS builds upon and leverages two other key technologies, as you will see, which are Xeno and YAX. One which is a content-centric networking protocol, sometimes also referred as named data networking protocol. The other one which is a decentralized key value store. And those two elements, as you will see in the remainder of the slides, are really at the core of FogOS, but are also technology that we think are extremely relevant to facilitate, as we will see, the development of systems that can really be decentralized while be scaling internet scale. Okay, so with that in mind, I will let now Gabriele introduce you to some of the technical details of FogOS and then take us through a demo. Gabriele.
So first of all, thank you, Angelo, for the very good introduction about fog computing. And let's start talking about FogOS. So in FogOS, we have a set of abstractions that we use to manage this cloud-to-thing continuum. The first one is the node. The node is just a way to identify a content of resources that are available and that we can use in this cloud-to-thing continuum we can manage. So for resources, we talk about networking resource, storage resource, computational resource, and I/O resource, which are very important for IoT. Another key abstraction for FogOS is the entity. The entity, you can see the entity as the application you want to deploy in this cloud-to-thing continuum. So it can be your IoT application, your telco application, also, or your IoT application. An entity is defined in using a directed acyclic graph with respect to dependency. So your entity can be composed by, let's say, the atomic entities, which are the smallest deployment unit that you can have on FogOS, or it can be composed also by other entities, as you can see in this picture. In this picture, we have an entity that is composed by a set of atomic entities, and then also another entity which is smaller. This helps to build, let's say, complex application leveraging very simple ones. So, for instance, if you want to deploy, I don't know, a smart home application, you can text some application very simple, like an MQTT broker, a client, or the Eclipse smart home project, and then you can deploy your smart home application. You can also define constraints about with respect to computation, like I have a VM that can run only on x86, I cannot deploy that on an ARM device. Or the most important are the constraints about the I/O, because if I need access to some I/O interface that I have to have access to that interface, I cannot deploy, for instance, that type of application on the cloud, because I will not have that interface. To dealing with this different type of entity, FogOS will use the plugin that we will see after. Also, for the entity, we defined a finite state machine, which is like a general one. So all sorts of entity can translate in one of these states. Obviously, the states means is different, depends on the kind of entity. Because if you think about a container or a VM, when you think about migration, it's a real seamless migration. While if you are managing a native application, well, the migration will not be seamless because you have to start and stop the application in another place. So the states still make sense, but the meaning is different. Then another key abstraction is the networks, because yes, you have defined your application that it's composed by a lot of small entities, and then you have to connect these entities. So you can define networks, which are vector networks, and you can define connection between different networks and entities and the networks. A very good thing is that you can span these networks across internet. So for instance, in the case I have, if you think about normal overlay networks, they work inside a local area network, but we are able to span these networks across the internet. So you can deploy your network really end-to-end. Obviously, this network can be connected to the internet, so your entity can have access to the external world, or they can be like a private network. So your network will be live only inside the FogOS domains. To describe all this, we have our information model, which is used to describe all sorts of resources that we can manage and that we can describe, and also to define the application that we want to deploy. This sort of our information model, it's represented in two ways. We have the JSON schema and also the Younger models. We will see in the next slide why we have the Younger models. Because a lot of people ask us, okay, but how you place your information model is with respect to the ETSI, MEC, and XNFB1. Well, we are a superset because we extended those two information models to also manage I/O constraints, which are not defined neither in MEC or NFB. Also, this is why we have also Younger models, because usually in this kind of domain, which is the telco one, when you define information model, we have the Younger models, which helps you a lot in defining, let's say, the relationship between different parts of your model. So now we can deep dive on the architecture of FogOS. We go bottom up. So we start with our NDN layer, which is based on Zeno. So it allows us to have, let's say, pub sub sort of NDN, so we can discover over the nodes thanks to the NDN, and this way we are also not aware of the real placement of the information, because in NDN you don't think about the host, but you think only about the content, which this helps us a lot when we want to share information about the resources that are on the network. Then on top of our NDN, we have our distributed key value store, which is YAX, which is based on Zeno, and allow us to, let's say, it's the control plane of FogOS. So all the information that we send and to deploy application, to start an application, to do migration, and so on, all the control plane is through YAX. Then on top of that, we will have the agent, which is the core part of FogOS. So in order to, let's say, to manage something, you need to have an agent running on it. So we can map like the node to an agent. So we can have an agent that can run on a VM, can run on bare metal, can run on a Raspberry Pi, on your PC, even on your mobile phone sometimes. So when you have an agent running, let's say your hardware will be, your resources will be exposed to FogOS. So you will be able to deploy application on that. And then we have the plugins that helps us to manage all this heterogeneity and all this software resource. In particular, if we go to see what we can do with the plugin, there are different types of plugin. Let's say the most basic one is the one that manages atomic entities. So it's the one that implements the state machine that we saw before. And so its work is just to manage that kind of entity. So if you want to manage a VM, you need to have a plugin, for instance, for KVM to manage VMs that runs on KVM. Same for Xen, or if you want to manage LXD container, you have a plugin that implements that state machine and maps it to the LXD state machine and the LXD API. Then we have the plugins for the networks, because yes, we see we can deploy networks, over networks across the internet, but if you think about, let's say, not so emerging partners like SDN, you need a way to manage also SDN networks. So talk directly to a SDN controller and talk directly to a switch to create VLAN and so on. So we need the plugin to manage that in a sort way. So we define that type. Then we have the OSs. So this is simple to understand. If you want to run on an operating system, we need a way to interact with that. So pretty easily. Then we have monitoring. It's a plugin that allows us to get information about the state of the resource and the state of utilization of that resource. And then we have two types of plugin which are pretty important, which are the resource orchestration and resource manager plugin. This kind of plugin implements the fog stack, which is the fog management and orchestration stack. So this means that if you think about, we saw the runtime plugin or the atomic entities plugin. That sort of plugin just manage atomic entities. So just manage the very, let's say, the simplest deployment unit that you can have on FogOS. While the resource orchestrator, resource manager plugin has to interact with the whole graph of atomic entities. So directly with the entities, because they have to decide where to place each part of the entity, or in the case of the resource manager, they have to decide where to replace in case there is bad performance or some constraints about, for instance, latency is not more satisfied. So I have to replace some part of the entity. So I have to do the reconfiguration of the network and so on. Also, there's two plugins that help a lot of the map between FogOS and the NFB and the Etsy NFB and MEC Manostacks, which people from telco are very aware of. So we try to bridge the fog to the telco, which is not so easy. And if you think about the runtime plugin, they just implement the virtual infrastructure manager part of the Etsy, from the Etsy point of view. Yes, we saw all this, let's say, very good stuff, but always we can interact with FogOS. The simplest way is using the Python API, because we provide some Python free API to interact with FogOS. These API are directly connected, for example, to the distributed store, so they will just write and read the resources on the distributed store. And our demo that we will show will use this API. Also, if you are more curious, there is the link, so you can find information about the API and all the documentation. Now I have to switch laptop to show you the demo. So, okay. Okay, first of all, what we will see in this demo? In this demo, we will see the real unification about storage computer network end-to-end. So we'll deploy an application along this cloud to thin continuum. So we will have an heterogeneous infrastructure, which is composed by a cloud server, which is our running only node. Then we will have an edge server running on our data center inside our office. And then we have the things that in our case will be 3 Raspberry Pis. We will have this heterogeneous resource to have an heterogeneous kind of application, because we will deploy an application that is composed by LXD containers and also by a binary application. So you will see that also applications that are not modified to run on FogOS, we will be able to deploy that. If they are containerized, it will be easy. If they are not containerized, we can also make that. let's say, to demonstrate that we can work also with applications that are not built for fog-OS, we will leverage on some Eclipse project. Like we will use Paco, we'll use Mosquito Broker, and also Eclipse Smart Home. So at the end, we will deploy a very simple smart home application. This is the topology of the demo. So you can see we have a physical network from which everything is connected. And then we will have the free Raspberry Pis and the edge server and the cloud server. We will deploy these different types of applications. So you can see there will be 4 LXD containers and 1 native application. And you can see that the containers will be mostly running Eclipse project like Smart Home and Mosquito. We'll also use DNS mask to provide a gateway and a DNS, and also hostapd to provide a Linux hotspot. So we will also provide, let's say, a network service, which in this case will be an access point. And then on Raspberry Pi, we will have a native application, which will leverage on Paco for connecting to the Mosquito and MQTT broker. And we will also provide the virtual network to connect all those sorts of entities. In this slide, so you can see the entity graph. So there are some entity that depends on the other. And the end-to-end unification is this is the way we will deploy our application. So we will have the MQTT broker on the cloud, the smart home server on the edge, and then we have the gateway, the access point, the sensor on the things. You can think that deploying the gateway on the things is not so smart, but this is what we want to do for this demo. Also because in the case you are deploying a gateway, maybe you want to have access to that gateway. You think gateway is just is a gateway from the network point of view, not from the IoT point of view. So it will not do translation about the protocols and so on. So this is why we put that on the things. And then if you want, you will also able to run the demo to your own if you want. You just you can there is the Git repository in which you can find this demo and also some other demos that show the fog-OS unification. Okay, that said, we switch laptop. So, okay, share screen.
Aspetta, faccio stop sharing.
Yes. So you should be able to see my screen. Okay.
Yeah, very good.
Okay, let me describe a little bit because there are a lot of terminals running on my. So we have a pairs of terminals. So for instance, this pair represents the cloud. This one is our edge server. Then we have one Raspberry Pi, second Raspberry Pi, third Raspberry Pi. Then here we will have our YAX running, but it's not important. And here is my Mac where I will start the script to deploy the application. The script uses the API, so if you want, you can just see the script, which is not so complicated. So our script just leverages on the API. So for instance, the first thing I do is just showing the list of nodes that are running in this moment, and then I will just do deploy with this API. Just add, I have my manifest for the application, I will deploy that. You can also check a manifest. So in the manifest, we have information about all the components of this entity. For instance, this is a fog-OS demo on a Raspberry Pi. I have information about the network that I want to deploy, information about all the components. So for instance, you can see that the broker is the gateway, the smart home appliance needs the gateway and the broker, and so on. Not go deep dive on this because it's just, you can find documentation on that. Okay, so let's do the deployment. First of all, I will start this. Started, not yet. Voilà. I'll start my YAX. Let's see. Started this, and then I will start the fog-OS agent on the nodes. It's pretty easy to start the fog-OS. You just fos minus agent start, and then just -b in this case because we want to be verbose, and -p to the directory of the plugin. So I will start the first one, then I will start the second one, third one, fourth, and 5.
And for instance, as Gabriele starts, plugin can be updated on the fly.
Yes.
Okay. But when you start up, it will start with the plugin that are in the given directory.
No. You can configure the plugin that you want to load. So in this case, for instance, I'm just loading plugin about networks and LXD or networks and native application. Okay, so all nodes are started, so you can see fog05 agent up and running on all the 5 nodes. The other screen is just to show, in this case, are the LXC list. So when the container will start up, you can see the containers running. So first of all, we'll start now our application. I'll click on board, and then I pass the manifest. You see the list of the nodes. The list of nodes is a runtime discovery. So for instance, if I shut down a node and I redo the node list, then that node will not be there. Now I'm starting deployment. You will see it's creating also the network. Voila. You see moving. Okay. You see I'm deploying the broker. Here I have deployed the the gateway. And then it will deploy the access point, as you can see here. So it says stop it. Now it will start. This one is the Raspberry Pi, so this is why it's a little bit too slow. But it's a Raspberry Pi, so you cannot have too much power. Then it will deploy. So it's running. You have also information about the, let's say, the IP address inside the LXD. Then it will deploy the smart home gateway. Okay, it's there. It takes some time because the smart home gateway, the smart home is pretty bigger compared to the other one because you have the Java. Okay, you see everything is running. In this case, I've deployed the native application, so you can see this new application showed up, like it's sensor.py. Okay, then if I want to show you that it's really working,
so I have it. Let's see if you can see the video.
Yeah, I think you have to share your camera.
Yeah, it's already live. So if you look at my screen, this is the. Hold on, let me go actually to the home page. Let's see. So this is, for instance, the
smart home
application that you can see the video. And for instance, actually, let me turn it around because you should be able to show the Raspberry Pi
with the sensors and so on.
And if I, for instance, here I turn it on, you see it turns on,
and then I turn off. It's pretty
turns off. Okay. And here there is the temperature, so we can try to warm it up, maybe with the fan of the. Not sure how much it will take. Yeah, it's really yeah, it went a little bit up, 32, 34. Yeah, yes, so it's going up. You see like it's really 35. Working. Yes.
The LED is still on. Yeah.
Okay, let me show this from a zoom in. And again, the LED is on, and if I try to do like that, I will turn it off. Here we go. Off, on.
So it's a pretty simple demo, but to show the power of fog05 to unify. Because remember that the broker is running on the cloud, the smart home is running on an edge server, and then you have the native application running on this Raspberry Pi, and the access point at the gateway running on other 2 Raspberry Pis. So
and this is the entire smart home home page.
It's just an LXD container with smart home.
Exactly.
Nothing so special.
Yeah.
It's just a. Yeah.
And again, as Gabriele mentioned, nothing special was done to deploy this, right?
The Mosquito probably is just a Mosquito installed on LXD. So yeah. Nothing stores. It's complicated. Then we can stop everything. So in this case, it will destroy all the containers, the networks, and the application running on the Raspberry Pis. It will take some time also because the Raspberry Pis are powerful, but not so powerful when you have to run LXD containers. But at least you can see that you can deploy that also. Okay, that's pretty much all. So
we go back to
Angelo's slides that will draw the conclusion.
Okay, so okay, so Gabriele, thank you very much for the demo. So I hope that was insightful for everyone. At least it shows that it's not just slide, right? That's always good. And as you saw in my early slide, in fact, this has been used in quite a few projects. And as I said, our robotic business unit uses it to deploy, for instance, ROS application, I believe for ROS1, right?
ROS2.
ROS1. Okay, so perfect. So just to wrap up, what is the path ahead from our perspective? I think from the ATO perspective in AT-Link, we are firmly convinced that in order to address the non-functional requirements that are characteristic and that we saw characterize industrial system, as well as preserve privacy of both institution as well as individual, we need to bring the control back to the edge. We need to keep the data close to the source, and we need to let the owner of the data decide what to share, how to share, and with who to share. Okay, so this is the problem that we are trying to solve. These are the technology that we are building for solving, let's say, or addressing this problem and coming up with products. In fact, in a way, don't force everyone into a specific model that just doesn't fit either from a non-functional perspective or from privacy perspective. So as an entity, as an R&D group, we'll continue to build this technology. We'll try to create as much open source technology as possible, because we think as a company that that's the way to really keep the ecosystem moving and to address a problem that so many people talk about. But in the end, we need technology, and I think we took a pretty bold step toward providing the building blocks for really addressing this domain. Obviously, this is a big, ambitious endeavor, but it will also cause a major shift in computing. So we can't do everything alone. Obviously, we want to build this future together, and this is why I think this last slide is really a call to contribution. So if you find this technology interesting, join our community, join our project, and let's make the edge happen together. So that concludes our presentation. I think at this point we'll be answering questions. And if you haven't done so, please type them in the chat. Thank you, everyone, in any case, for your attention.
Thank you both. We have a few questions. Actually, many of them are along the same lines. I think it started with Davide. I think if MQTT can be used as the transport protocol for like all the orchestration stuff, and I think like you're definitely using MQTT in the demo, but can you clarify whether this can be like at the wire level, basically for
so we have to distinguish two things, right? What fog05 uses. So fog05 doesn't use MQTT. fog05 uses Zeno. And I'll explain why. So Gabriel already went through it, but I'll go a little bit further. So MQTT in the demo, and in fact, actually, let me go to the slides of the demo. We were provisioning an application that was using MQTT. So if we go, I believe this is a slide, yes, that shows the deployment. So we were provisioning MQTT brokers and MQTT application. So we are the infrastructure. Then the application or the middleware that you run, we actually don't care. Okay, that's your choice. On the other hand, why don't we use MQTT at the bottom of our infrastructure? So the reason why we use Zeno, well, there are a few. Okay, first of all, we can't always assume that we have an IP network. Okay, so if you look at this diagram, Zeno can sit on top of a data link. Sometimes we need to provision an IP network, and there is no IP network. We just have Ethernet. So we need, first of all, a protocol that can work at a data link level. We need a protocol that is extremely wide efficient. You could argue MQTT is wide efficient, Zeno is more, and there are a few, if you want more information, we have, there is some information available on zeno.io, but we can provide more. But very important, there is an aspect of scalability and decentralization. And so that's why we came up with this protocol, which, as Gabriel mentioned before, it's really an NDN. It's a named data networking that allow us to completely neglect addresses and address information. And if you think about what fog05 does, in the end, our system is very dynamic. We need dynamic discovery. We can't rely on addresses because they change all the time. Not all the system might be running on the same network either, okay? Meaning physical technology. So everything is addressed and discovered through the NDM. And then, as Gabriele mentioned, On top of this, we overlay this decentralized key value store that heavily draws on the primitive of Zeno in order to actually build the control plane of FogOS. You want to add something, Gabriele?
No, that's
Yeah.
good.
Okay, thank you. Well, there was a question whether FogOS is open source from Vipin, but I think this has been mentioned a couple of times in the meantime. So yes, FogOS is definitely open source, and people can this is the link to the GitHub space. So github.com/eclipse/fog05. Another question from Andre. Can you describe the data model, event, reading, etc., and queries that are supported in order to react to the data?
In order to react to
the data.
Okay. So what do you mean about react to the data? Because when in our in YAX, please go ahead.
Well, my guess is that maybe this is something that's not necessarily supported by FogOS proper, but it's more something that an application like Smart Home running on top of FogOS can provide, right?
Okay, so I think maybe one way of interpreting, and maybe that will be my answer, but happy to follow up. Maybe what it means is that obviously the information model is data for FogOS, and as the topology of the system changes, the information changes. So how do we react to that, and how do we discover that?
Because we have, we leverage on YAX, so we have some sort of pub-sub communication. So we can also subscribe to changes in the network. So in the case, for instance, there is some nodes that is not there, or something strange happens, we are subscribed to that sort of resources, and we will get the information we can react. Because there is also in the information model we have also the structures of the URIs that you use in the key value store. So it's well defined the way the keys you have to observe, the keys you have to register, to subscribe in order to get information and about changes in the network topology and so on.
And I think there might be another way also of interpreting that question, which is perhaps if FogOS provides the equivalent of any pass for sharing and reacting to changing data. So in that respect, what we have done, because we have designed YAX just for ourselves and for FogOS, but when people started appreciating the architecture of YAX and how we use YAX, they asked to expose it potentially as a service that you could have application level on top of FogOS. So technically, you could deploy YAX using FogOS, but that will be your own instance, okay? So that's a possibility, and that's something that in some of these projects that I mentioned at the beginning of the presentation.
The 5G Coral architecture, because for instance, in 5G Coral, the FogOS will be used to deploy some sort of service platform, which is in 5G Coral will be an MQTT broker. So in that case, for instance, if there is an application interested to data provided by other application or by the FogOS itself, it can find this type of data inside the service platform, which at the end is a MQTT broker.
Or if you want, you could deploy a YAX instance.
Yes, it depends on you.
It's your choice.
Yes,
exactly. It's really your choice.
Okay, thank you. Another question. There's lots of questions, so that's more minutes. If people have more. Question is, are you targeting industrial use cases, especially
Benjamin, we lost you.
Oh, really? Hello?
Yeah, now we can hear you again.
If you got the okay, so I'll do that again. I was saying that there are lots of questions, which is great, and we have a few more minutes to take more if there are more questions. One is, are you targeting industrial use cases, especially OT type monitoring and control systems? And if yes, I guess, is there an industrial demo available?
Yeah, so just as I mentioned in the beginning, AD-Link manufactures hardware. We have our own factories. Okay, so many of the use cases we have in open fog test beds and some new initiative we are starting in Asia are precisely related on industrial and manufacturing. Why Asia? Well, because most of the production in the world is over there, because our factory are there, and as it's far more convenient. So the short answer is yes, and the long answer is yes, because that's interesting for us in a selfish manner as well. Okay.
Okay, sounds good. So I think we're probably running well, 1 out of time and 2 out of questions, but there's only like a few more minutes while maybe I start wrapping things up. A couple things. One is with your permission, Angelo and Gabriele, we will be posting a link, including the link to your slides in the description of the YouTube video, so that people have this as a reference. And I also wanted to remind everyone that our Open IoT Challenge is welcoming. Well, it's currently in the phase where we are asking people to submit their proposals. So, as a reminder, the Open IoT Challenge is an opportunity for you guys to you folks to work on cool open source technology. So whatever interesting IoT use case you have in mind, and you need an excuse to start actually working on it, the Open IoT Challenge might be a good opportunity for that. I will be actually sharing my screen just now so that you can have the link to the website. So give me just 1 second here. There. All right. So the Open IoT Challenge. So you have until December the 7th to tell us what you would like to build, what kind of technologies you are planning on using, and actually, I would love to see people using fog05 and technologies around the fog05 ecosystem and for computing in general. And come December 7th, our jury will be looking at the best proposals, and the 10 best proposals will be granted and will be given some cool gifts like hardware gifts from Intel and some gift certificates for you to buy the hardware that you may need to effectively build your solution. And then you will have until April basically to actually work and build something and build what you said you would like to build. And come basically end of April, our jury will look at this time not the best proposals but the best projects basically, and the grand winner will go home with basically thousands of dollars of cash basically, and a few more prizes. So yeah, go and check out iot.eclipse.org/open IoT challenge. I guess the bar is pretty low between now and December 7th, because you just need to write down your thoughts briefly and tell us what you would like to do. There's no I mean, yeah, it's pretty easy, and yeah, I would love to hear from you guys what you would like to build. So with that, yeah, I don't see more questions in the chat, so I guess this is time to thank Angelo and Gabriele again for your time. Oh yeah, I was wondering whether we would see Gabriele in.
Yeah, in this. Yes, I'm
so yeah, thank you again for people watching the replay and the recording. Feel free to use the comments in YouTube, the YouTube comments to ask any follow-up questions that you may have. And yeah, with that, thanks everyone for attending, and we will be back in just a few weeks for another virtual IoT meetup. Thank you, guys.
Okay, thank you. Bye.